Hey guys, in this video I'm going to show you how to draw the Lewis dot structure for C9H20, which is nonane. So here we go. Got C9H20, which is the chemical formula for nonane, and this is going to give us 9 carbons, each with 4 valence electrons, plus 20 hydrogens, each with 1 valence electron. It's going to give us a total of 56 valence electrons. Okay, and in this video I'm just going to show you the straight chain structure. There might be other ring structures, but this is just one of the more basic ones. So let's go ahead and get started. Hydrogens cannot be central bonding atoms because they can only bond once. So that means that the carbons are going to have to be in the center bonding with everything else. So let's go ahead and draw out these 9 carbons. Kind of a lot. Okay, 9 carbons, and then we have the 20 hydrogens. Alright, so that's 20 hydrogens. Now each H can only have a single bond because they can only hold 2 electrons each. So we can go ahead and connect them all to the carbons with a single bond to their nearest carbon atom in this structure. Alright, so now this should be the right structure. We can go ahead and count up the bonds and see that it is in fact the right number of bonds, therefore leading to the right number of electrons. So let's go ahead and do that. 1, 2, 3, 4, 5, 6, 7. Okay, I got 28 bonds, each with 2 electrons, and that's going to give us a total of 56 electrons, which is what matches up to the original calculation. So that's very good. That's what we're looking for. Okay, now we can go ahead and check the formal charges just to verify that this is a correct Lewis structure. So the formal charge is on the carbon, and if you notice in the structure, every carbon has 4 bonds and no non-bonding electrons. So this formal charge calculation will prove to be the same one for every single carbon in this Lewis structure. So formal charge is number of valence electrons brought in, which is 4 for carbon, minus each one is 4 bonds, minus 4, minus 0 non-bonding electrons on the carbons. That gives us a formal charge of 0. And we can now check the formal charges on the hydrogen, which is going to give us 1 valence brought in, and notice every hydrogen only has a single bond going to it. So one valence electron brought in, minus 1 bond, minus 0 non-bonding because there are not any in there, and that also gives us a 0 formal charge. So if you were to sum up all the formal charges, the overall formal charge that we would calculate in this entire Lewis dot structure is going to be 0, which is what you want when we're dealing with a non-charged compound or molecule, just like the C9H20 is. Okay, so that's good. Now we can go ahead and talk about shape real quick. If you notice how I said before, each carbon has 4 bonds, which means that each carbon is going to have a sp3 hybridized orbitals. So each carbon is sp3 hybrid. And that's because each one has 4 bonds around it, 4 bonding sites. And that also means that every carbon is going to be at the center of a tetrahedral shaped molecule within the overall compound here. So the C9H20 shape is just a bunch of tetrahedrals kind of building off of each other in certain ways, okay? And notice that this is a symmetrical, this entire structure is symmetrical with each H opposing each other. So the overall net dipole moment is going to be 0 because every atom cancels out with a second atom. So this is going to make this compound become a non-polar molecule because the net dipole moment is going to be 0 for the overall compound. That's pretty much it. If you have any questions, leave them in the comments, let me know. If you have a special request, let me know. I'll try to put it in a video for you, and thanks for watching.